Although it may seem like it sometimes, weather forecasters don't just make up their predictions. They use the best available science as well as three key variables that are critical to understanding weather: air pressure, temperature, and air density. These variables are essential because, like a well-organized set of drill sergeants, they control how air behaves and thus they control the weather. However, they are not mutually exclusive. Like a set of siblings, each variable is closely related to the others, whether they like it or not. Let's look at air pressure first. Though you can't see them, air is a cocktail of molecules that fly around and bump into each other. Think of the molecules as billiard balls. As they bump into each other, they push each other around. You aren't going to notice one molecule bumping into another one, but if you add up all these tiny collisions and pushes, you might start to feel it. These molecules also have weight, and between the weight of the air pushing down and the collisions between molecules, we get air pressure. So how does air pressure relate to temperature? Well, remember how I said the air molecules are moving around and bumping into each other? If they move faster, they bump into each other harder and more often. This happens when the temperature of air is increased. Warm air molecules have more energy, so they move faster and create more pressure. Likewise, cold air has less energy, and therefore exerts less pressure on its surroundings. Density also plays a role. The denser the air is, the more molecules there are in that given space. It's like the difference between having a large party packed into a tiny living room versus having that same large group of people in a big recreation hall. The denser the air, the more collisions there are between molecules because there is less room for them to avoid running into each other, so we get more air pressure. So you can see that density, temperature, and pressure work together to change the conditions of the air. When heat is added, air temperature and pressure both increase. And when the density of air changes, the pressure, and sometimes the temperature, does as well. Now that you know how the three variables work together, let's take a look at how they affect weather. Adiabatic processes come about when air changes temperature without any gain or loss of heat. Huh? How on earth does that work? Well, this is where density comes into play. Remember our partygoers from before? If you put them in the tiny living room, they bump into each other more. The molecules in dense air do the same thing, and these collisions give off heat and create pressure. When there is more space to move around in, the molecules run into each other less, which means they give off less heat and pressure. And because air has weight, it's affected by gravity. So, nearer to the ground, there is more pressure because there's more weight. As you rise in altitude, the weight is less, so there is less pressure and more space for the air to expand. This means fewer collisions, less pressure, and less heat. You can see this process along mountainsides. As warm, moist air rises up the side of the mountain, known as the windward side, it expands because there's less pressure, and it therefore cools. As it blows over the mountain and comes back down on the leeward side, it gets compressed, which makes the molecules bump into each other more, and the air is then warmed by these more frequent collisions. This is why the windward side of a mountain has its name. This is where the wind first encounters the mountain. It's also why the windward side is rainy and the leeward side is dry. Cold air can't hold as much moisture as warm air, so as the warm air rises up the mountain and becomes cooler, the water it holds is squeezed out of the air as rain on the windward side, and dry air continues on to the leeward side. Do you think that if air rising up a mountain creates rain on that side, that it also must create a cloud? If you said yes, you're right. Air pressure, temperature, and density all contribute to cloud formation. As warm, moist air rises up into the atmosphere, it cools, which, as you now know, means that it has to let go of the water it brought along with it. The water from the air condenses into tiny droplets, which is what clouds are made of, and the type of cloud that forms depends greatly on the surrounding air, its pressure, temperature, and density. Air masses are huge parcels of air that cover large portions of Earth's surface, much larger parcels of air than the ones we've been talking about so far. As we learned in another lesson, each air mass has specific characteristics, and when they meet up, they can produce an interesting variety of weather conditions. Whether large or small, when air parcels meet, we get fronts. The differences in the temperature, pressure, density, and moisture content of the air masses makes one front slide over the other one, which can affect weather patterns by creating cloudy skies, thunderstorms, and gusty winds. Fronts are like fights between air masses. Since they're so different, it almost feels like they can't decide on the weather, and the storms that follow are their conflicting opinions. Our three variables also influence other weather patterns, such as thunderstorms, tornadoes, and hurricanes. Thunderstorms occur when warm, wet air rises quickly. This rising air is called an updraft. The updraft builds a large vertical cloud. The water inside the cloud falls back toward the ground, and as it does, it tries to convince all of its friends to come along with it. This collection of water droplets builds up until larger water droplets form that are heavy enough to push past the updraft and reach the ground as rain, creating a downdraft or downward moving air. When the air inside a thunderstorm cloud begins to spin, we get tornadoes over land and hurricanes over water. The combination of low-pressure centers and high-pressure exteriors drives these dangerous storms along until they're stopped by opposing winds or run out of energy. Like a set of siblings, air pressure, temperature, and density are related to one another. Air pressure describes the collision of molecules and weight of air pressing on its surroundings. Temperature refers to how warm or cold air is, and the density of the air is how many molecules are packed into a certain space of air. Air pressure is influenced by temperature because as the air is warmed, the molecules start moving around more, so they bump into each other more often and create more pressure. But air pressure also affects temperature. The more those molecules bump into each other, the more heat they generate, so more collision means warmer air. Density is also important because, like our big party of people, if you pack more molecules into a given space, they're inevitably going to bump into each other more, creating more pressure and therefore more heat as well. This is how we can have air temperature changes without adding or removing heat, known as adiabatic processes. As air rises up the windward side of a mountain, it expands, which means our party-going molecules have a larger space to move around in. There are fewer collisions, so the air cools. But as air cools, it can't hold as much water, so that water gets pushed out as rain on this side of the mountain. Any air that continues over the mountain to the leeward side gets compressed as it sinks back down to the ground, which means the party gets moved to a smaller room and we get more collisions, and therefore warmer air. However, most of the moisture was left on the windward side as rain, so the leeward side is dry. The family of air variables is also responsible for clouds, air masses, fronts, and storms. Fronts are like fights between differing air masses, and their storms are their disagreement. Clouds form when warm, moist air rises, just like over the mountain, which sometimes release their water as air. If the cloud grows tall enough, we get a thunderstorm cloud, which can lead to tornadoes and hurricanes if the air inside starts to spin.